This is John Black, Super Chemist. We're here to make some silver nitrate. Here's my apparatus. First of all, I got 2 bars of silver, and I got my Erlenmeyer flask here. You can see it comes, I got a rubber stopper. Rubber stopper comes out, goes down through my bubbler. If you saw my other video where I made a bubbler, you'll know what it is. I have sodium hydroxide in 2 of them. 2 of them are empty to prevent suckback. Now at the end, instead of having a funnel, go into another thing of sodium hydroxide. I got this. It's a pump. As you can see, I can squeeze it. You can see the bubbles coming. So each time I press it or pull the trigger, pull some air up, cause a vacuum. Hoping that'll help suck some of the nitrogen oxides I make out of the reaction and get it to react with the sodium hydroxide, make sodium nitrite. Now when I add the nitric acid, it'll start reacting. It'll make the oxides, as you'll see soon. So as you can see, I got 30 milliliters of water. I'm going to put that in here first. A 100 milliliter flask, so I'm guessing it's about 62, 63 milliliters. Crap, it's already heating up. You can see it's already starting to get some, see the white. You can see all that. That's silver nitrate. Alright, so when I added that, it was from the freezer. So it was cold. The water was just from the tap water. You can see when I added them together, they heated up. Now this has been sitting here for a while. I turned the heat on in the hot plate, 85 degrees. Actually turned the fume hood off. As long as I pump this every once in a while, I can barely smell it. So it's always best to have the fume hood on if you have one. So it's just a waiting game now. I just gotta wait, keep it making sure it's hot, and that's it. When it gets done, we'll go from there. That's the last bottle. First bottle. Second bottle. Third bottle. The last bottle, you can see it's starting to get a little murky, but still the gas hasn't got to that bottle yet. So I know I'm scrubbing pretty good. I got it up to where I'm shaking it, and I don't hear any metal hitting the sides of the glass. So I'm guessing that's about it. I'm gonna throw another bar in there. Alright, as you know, I put another bar in, and it's still boiling. I don't know if you can see. But everything's starting to clear up. You can almost see through the bottle, and the first bottle is right there. Look at that second bottle. That second bottle's already cleared up. The third bottle. And the fourth bottle was always clear. Look at that. Right after the second bottle, which has the first wash. See how nice and clean it is? That's an empty bottle. This has the sodium hydroxide. And then look when it comes out of there. It's all clear. I'm trying to heat on a little bit more. And see if I can keep it going until it doesn't make any more nitrogen oxide. As you can see, there's no more gas coming off. Actually, it's boiling right now, and it's distilling pretty much. And no more nitrogen oxide gases are being produced. So that must be like really, really dilute acid. But I'm going to let it boil for a little bit, and then that little piece in there. It's like a really thin piece, so I'll take it out of there and filter it. I got little pieces of rubber in there, so I'll have to filter that out. Also, it did start puffing through that last bubbler there. Basically, I just threw some sodium hydroxide in there, and it cleared it right up. I shook the bottle up a little bit to get the gas out, and it stopped doing it. So I turned the heat off, and this is basically I'm gonna let it go, like I said, and filter it out. Hopefully, most of that silver will be gone. It's really thin right now. Maybe it'll all be gone. All right, so I gave up on the heating it. As you can see, well, you can't really see, but it screwed up my thing. Here, you can see it on here. See right there, that's part of my rubber stopper. Let me clean that off first. As you can see, little particles on the side there and inside. See them floating around. So, and you can see the crystals. So I'll put some water in here, shake it around, pour that in. Do that a couple times. That's nice and clean. Yeah, precip right there. So that's what all that white stuff is on top. Basically, I'm going to filter that out, get all that rubber crap out of there, and then recrystallize it. Seems like it's already saturated, obviously, because it's pre-sipping out. As you can see, there's my silver nitrate. Alright, I let this sit on the radiator till it mostly evaporated. There is actually a little bit of water still in there. It's like slush. As you can see, I got the crystals in the glass funnel. Turn on my vacuum. push down on it. Wash it with ice cold water. Well, that bottom container, I'm going to recrystallize that and mark it almost pure. And that's all pure silver nitrate. Here's my stoichiometry. I want you to realize that when you put a metal in acid, normally you get the metal salt of that acid plus hydrogen. Okay, meaning if this is hydrochloric acid and this is iron, you get iron chloride and some hydrogen. If it was zinc, you get zinc chloride and some hydrogen. But when you put metal in nitric acid, it's a little bit different. When you put this into there, you still get your metal salt of the acid, right? Because you got nitric acid, so you get the metal nitrate. But instead of evolving the hydrogen, you're evolving NO2 and actually a little bit of NO also, but it'll easily oxidize to this just from the oxygen in the air and water. Um, so here's what we did. You need twice as many moles of the nitric acid than you need of the silver. 1 mole is 108 grams. Now I have bars, so I'm kind of normally I like to do like 1/10 of a mole, a half of a mole, or a full mole. In this case, we're kind of screwed because the metal bars, it's not like I can cut them down into smaller pieces. Uh, so I have 2 bars is 63 grams. That's 58% of a mole. Let's just say that's a half a mole for right now. So if we have a half a mole, we need twice as much over here. So we need a full mole of the nitric acid. Now, a mole of nitric acid is 42 milliliters per each mole. I multiplied that by 1.5 for 2 reasons. One, once this stuff reacts and you're down to the last bit of it, your nitric acid is going to be so dilute, it's not even going to work really. So I did want to put an extra half mole. And the other reason is this is actually a little bit more. If you times that by 2, you get 1 mole, 0.16 or whatever percent or whatever. So me going to 1.5 is good. And the last reason is that's pretty much exactly how much nitric acid I have. So I'm kind of stuck with that too. All right. Now my nitric acid is fuming, and it's really concentrated. I'm going to say it's 100%, even though it's probably not. And so I want a 68%, which is concentrated, but I'm going to say 70 because it's a nice even number. Okay, and plus 70, it could be considered concentrated, anywhere between 68 and 70%. To do that, I just divide by 0.7, and then I'd know that I needed 90 milliliters total with water. So I'm going to get my 63 milliliters, I'm going to put it in there and add water until I get 90 milliliters total. That's going to be approximately 1.5 moles to 58% of a mole. Stoichiometry, instead of 2 bars, we used 3, and it pretty much almost went to completion, which means we needed 73, that we had to have had 73 milliliters of nitric acid there. And I know I did not have that much. So the only thing I can assume is that the nitrogen dioxide that came off went back into solution to create more nitric acid, and that's what reacted with the silver nitrate. So you definitely don't need to put excess into this, that's for sure, if you heat it up. Always remember, science is great.